Chapter 6 of the Western United States. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. The Western United States, A Geographical Reader, by Harold Wellman Fairbanks. Chapter 6. Something about Earthquakes and Mountain Building. Our everyday experiences lead us to feel that nothing is more permanent than the features of the earth upon which we live. Great cities containing costly buildings are built by the water's edge with the expectation that the ocean will remain where it is. The building of railroads and canals and the establishment of industries to make the earth more fruitful and better adapted to our use are based upon the idea that the mountains and valleys, with their various climates, will not change. The study of history, however, makes plain the fact that at different times in the past certain portions of the earth have been visited by destructive changes. Cities have been shaken down by earthquakes, and the ocean has swept in over the land, drowning thousands of people. Even the mountains, which stand upon broad and firm foundations, sometimes bring disaster, by means of avalanches and landslides, to the people who live at their bases. The truth is that the earth's surface is everywhere slowly and quietly changing, but our lives are so short and the history of even the oldest cities is so brief in comparison with the rate at which most of the changes take place, that we as a rule are aware only of the uncommon and sudden ones. The occurrence of earthquakes establishes the unmistakable fact that there are forces at work from within, disturbing the surface, while landslides and even little gullies washed out by the rain show that other forces are working from without. The vibration or trembling of the earth, which we call an earthquake, always arouses alarm, and frequently occasions great destruction and loss of life. Only a few of the various causes that may bring about earthquakes are as yet fully understood. Earthquakes are very interesting, however, because they are often associated with the birth and growth of lofty mountain ranges. Volcanic eruptions, hot springs, and the high temperature which exists toward the bottom of deep mines show us that the interior of the earth is very hot. It is thought that at one time the whole earth glowed with heat, but as ages passed, it became cold upon the outside and a solid crust was formed. Every one has observed that fruit becomes wrinkled as the pulp within dries and contracts. The materials of the earth occupy more space when they are hot than when cold, and as the interior portion is still cooling, the outer layer or crust continues to shrink down upon it, forming folds or wrinkles, as in the case of the skin of an apple. There is probably no portion of the surface that is fixed in its present position. The land is either rising or sinking continually. If the area that is pushed upward is large, it becomes a plateau, but if long and narrow like a wrinkle, it forms a mountain range. We should not be aware of these movements in many cases if it were not for the horizontal shelf cut upon the borders of the land by the ocean waves. Along some coast, old wave-cut cliffs stand hundreds of feet above the present ocean level. Other coasts have sunk, so that the water has flooded the adjoining land and made a new shoreline. When the movements of the land are sudden, they manifest themselves to us through earthquakes. The crust of the earth is not so flexible as the skin of an apple, and when the strain upon it becomes too great, it suddenly breaks. The rock walls usually slide past one another along such a fracture. If the rising wall becomes high enough, it will form a mountain range. The great mountain systems border the oceans, for the lines of weakness occur where the land dips steeply down beneath the water. It sometimes happens that the fractures in the rocks where mountains are being made are situated underneath the water, or in some position where water passes down through them in large quantities. What do you think would happen if such an underground stream of water came in contact with hot or molten rocks far below the surface? Note the effect produced by drops of water falling upon a hot stove. Each one, as it strikes, is partly changed to steam with a slight explosive sound. The result is similar when water is turned into the hot and nearly empty boiler of a steam engine. An explosion is sure to follow. When the pressure of steam suddenly formed within the earth is too great, a volcanic explosion takes place at some point where the overlying rocks are weakest, probably on or near one of the lines of fracture about which we have been speaking. The explosion is accompanied by thundering noises, tremblings of the earth, and the hurling of rock and molten lava into the air. That the rocks of the earth's crust are elastic is shown by the rebounding of a pebble thrown against a large boulder. If a file be drawn across the edge of a sheet of tin upon which sand has been sprinkled, the tin vibrates over its whole extent, as is shown by the jumping of the sand grains. Because of the like elasticity of the materials which make up the surface of the earth, the vibrations produced by an explosion are carried through the solid earth for hundreds of miles. The records of earthquakes show that they are much more violent and occur oftener where the crust of the earth is being disturbed by folding. We have seen that there are two main causes of earthquakes: the slipping of portions of the earth past each other along a fissure, and the contact of water with very hot rocks far below the surface. It is probable that the earthquakes which occur so often in the western portion of the United States are due to the first of these causes. The numerous extinct volcanoes show that at one period this region was frequently shaken by explosive eruptions. Mono Lake, at the eastern base of the Sierra Nevada range, has been a center for explosive eruptions, which were extremely violent at one time. The islands which rise in the lake are shattered, while Black Point, upon the northern shore, has been uplifted by an explosion from beneath, which split the rocks apart and formed deep fissures. It is an interesting fact that in the Cordilleran region the mountains have been increasing in height in very recent years. We might almost say that they are growing today. In this region, then, we can actually see how mountains are made. We do not have to depend upon descriptions of the manner in which they are supposed to have been made thousands of years ago. Any good map will show that the mountains of the Cordilleran region have in general a north and south direction. Their direction was determined by fissures formed long ago in the crust of the earth. Movements have continued to take place along many of these fissures up to the present time, and probably will continue for some time to come. In order to become better acquainted with these remarkable mountains, let us examine some of them, taking first the Wasatch Range in eastern Utah. The range has an elevation of nearly 11,000 feet, rising gradually upon the eastern side, but presenting a bold and picturesque front upon the west, toward the plain of Great Salt Lake. A short drive from Salt Lake City brings us to the foot of the range, at the mouth of Little Cottonwood Cañon. A peculiar bluff, which extends for a number of miles along the base of the mountains, at once attracts our attention. The steep face of the bluff, which is from 50 to 75 feet high, appears to have been formed by a rising of the land upon the side of the mountains, or a dropping upon the valley side. There are reasons for believing that the formation of the bluff was due to the occurrence of an earthquake, some time within the last century. The bluff is closely related to the mighty mountains behind it. It was formed by the last of a series of movements in the earth which raised the great block known as the Wasatch Range to an elevation of 6,000 feet above the plains at its base. Is it to be wondered at that the disturbances of the earth which result in the erection of mountains of such height are frequently so severe as to destroy the strongest buildings? Now let us go westward across the various parallel ranges of the Great Basin to Owens Valley at the eastern base of the Sierra Nevada mountains. This is the highest and longest continuous mountain range in the United States. For a distance of more than 100 miles, its elevation is from 12,000 to over 14,000 feet. Owens Valley was in 1872 the center of one of the most severe and extensive earthquakes ever recorded in the United States. The little village of Lone Pine, situated in the valley below Mount Whitney, was utterly demolished. 20 people were killed and many injured. a portion of the valley near the village sank so low that the water flowed in and formed a lake above it. The land was so shaken up that the fields of one man were thrust into those of his neighbor. For a distance of several hundred miles to the north along the base of the mountains the earth was fractured, and bluffs from 10 to 40 feet high were formed as a result either of the dropping of the surface of the valley upon the eastern side or of the raising of the mountains upon the west. This slipping of the earth which gave rise to the earthquake bluffs was the most recent of a long series of similar events which have raised the precipitous eastern wall of the Sierra Nevada mountains to a height of 2 miles above Owens Valley. If you will go out into the center of the valley and look west toward the mountains, you will see 3 bluffs or scarps. The first, which is 20 feet high, was made at the time of the last earthquake. The second, known as the Alabama Hills, and rising about 400 feet, was formed at an earlier time. The third, rising back of the others, is that of the main Sierra. Similar cliffs appear at the bases of other ranges of mountains in the Great Basin. Springs abound along these fractures in the earth, for the surface waters have an opportunity to collect wherever the rocks are broken. Numerous fertile valleys mark the line of earthquake movements, for the broken rocks and abundant springs favor rapid erosion. Among the coast ranges of California there appears a series of fractures in the earth which form a line nearly 400 miles long. They extend from a point near San Bernardino in a northwesterly direction to the neighborhood of San Francisco. Severe earthquakes have taken place along this line since the country was settled. The pressure and grinding of the earth upon opposite sides of the fissures has formed long, low ridges of earth. Small valleys have been blocked, and the old stage road from Los Angeles to Bakersfield, which followed the course of the fissures for a number of miles, has been almost obliterated. Hundreds of cliffs and mountain scarps throughout the West have come into existence as the results of movements such as we have been describing. Where the disturbances have been recent, the mountains are bold and picturesque. Those produced in earlier times are in many instances so worn away that it is difficult to tell with certainty how they were made. End of chapter 6.